so we're going to look at the homework for 2-4 day 2. And the first question, we have a function, and hopefully it's not too difficult for you to read. It's t to the 5th minus 3 times 5t squared minus 3t minus 1. So in order to take its derivative, I could either use the product rule since it's a product of two functions, or I could choose to distribute this all out. So distribute here, and distribute here, so that I no longer have the product of two functions. So that's my choice. I'm going to multiply t to the 5th times 5t squared, and then t to the 5th times negative 3t, and then t to the 5th times negative 1, and then negative 3 times 5t squared, negative 3 times negative 3t, and negative 3 times negative 1. And this is a function that I can take the derivative of easily with the product or power rule. 7 times 5, drop the degree to 6, 6 times negative 3, drop the degree to 5, negative 5t to the 4th, negative 30t, and 9. So it's easier to do that than it is to do the product rule. Here, again, easier to take the cube root of x and distribute it through x plus 1. And that way I don't have to use the product rule for this either. So x, the cube root of x times x is x to the 1/3 times x. And the cube root of x times 1 is x to the 1/3. So all I really need to know before I can take the derivative is what x to the 1/3 times x is. And that's x to the 4/3. So now I'll do the power rule again. 4/3 x to the 1/3, 1/3 x to the negative 2/3. And now I need no negative exponents. So one solution is to move the x to the negative 2/3 to the denominator. Another solution would be to factor out. So if I wanted to go another way with this, I could notice that there's a 1/3 I can factor out, and I can factor out x to the negative 2/3. And then I'll be left with this 4 and the x, because 1/3 minus negative 2/3 is 1. And then over here, I would just be left with the number 1. So this is an alternative way of writing the answer. And it is what you would get if you took this answer and got a common denominator. So either this or that is fine. For number 3, we have something that looks like a quotient, but we know because the denominator is a monomial, we do not need the quotient rule. We can rewrite it as two different fractions, and then we can use our rules of exponents and do 1 minus 1/2 and rewrite this as x to the 1/2. And here we can take 0 minus 1/2 and write it as 2x to the negative 1/2. That will allow us now to use the power rule to take the derivative. So the 1/2 comes in front, and the degree is negative 1/2. The 1/2 times 2 is negative 1, and then I drop the degree to negative 3/2. I can move my x's to the denominator if I want, or I could factor out an x to the negative 3/2 and stick a 2 over 2 here and also factor out a 1/2. So I'll be left with my x here, because negative 1/2 minus negative 3/2 is 1x. And then here I'll have the 2 left. And my final answer with no negative exponents could look like that. but it also could look like putting these into the denominators. All right, so number 4, we're stepping up a bit. It says find the equation of the tangent line. So that means that I need to use the point slope form. And if I want to go through this point, this is my y1, this is my x1. Y minus y1 equals a slope, which is yet to be determined, x minus x1. So the slope I get from the derivative. The derivative of this function when x is -3. That's what's going to go in here. So how do I take the derivative of this function? Well, it's x squared minus 4 times itself. So I will take the derivative by FOILing out and then just using the power rule. So the derivative of my function is 4x cubed minus 16x. When x is -3, that's 4 times -3 cubed minus 16 times -3. And so when you evaluate that, you're going to get -60 if you do it on your calculator. And that's what's going to go in here. That's your slope, the derivative when x is -3. And then what Webassign is going to want you to do is distribute and move the 25 over. So your final answer will look like -60x. You're going to have a -180 that you're adding 25 to, -155. So we're using point slope and then using the derivative to get the slope. For number 5, it's the same. And we did this in class. We did one a lot like this in class. And so what we did was we imagined our x plus 2 over 1. And we imagined our x minus 9 over x plus 1 being multiplied with that. So the function that we were using looked like x squared minus 7x minus 18, when I FOIL this out, over x plus 1. And in order to get the slope, we need the derivative. And in order to get the derivative, we need the product rule. So we're going to square the quotient rule, because this is a quotient and this is not a monomial. So we're going to square the denominator, start with the denominator, take the derivative of the numerator minus the numerator times the derivative of the denominator, which was 1. So the quotient rule goes like this, if you don't remember. Denominator squared. Denominator times derivative of the numerator minus numerator times derivative of the denominator. And that's how we're going to use the quotient rule. So now I need to plug the number 0 in, because I want to know what g prime of 0 is. So that looks like 0 plus 1, 0 minus 7, 0 minus 0 minus 18, all over 0 plus 1 squared. So when we calculate that out, I have -7 plus 18 over 1. And -7 plus 18 is 11. So that's my slope. And the equation of my line, y minus -18 equals 11 times x minus 0, or y equals 11x minus 18. Because it's plus on the left, it'll be minus on the right. So same kind of question as we did in class. Number 6 is one we did not get to in class. It's asking, where does the graph have horizontal tangents? And horizontal tangents are where the derivative is equal to 0. So I do need the derivative for this problem, but I'm not going to plug an x value in. I'm going to ask what x values make that derivative 0. So for my derivative, I need the quotient rule again. This is a quotient. This is not a monomial. So I'm going to square the denominator, start with the denominator, take the derivative of the numerator, minus the numerator times the derivative of the denominator. And I'm going to ask myself, when will this equal 0? Well, fractions only equal 0 when their numerators equal 0. So I don't need to worry about the denominator. I just want to know when 2x squared minus 4x minus x squared is going to equal 0. Or when x squared minus 4x is going to equal 0. Or when x times x minus 4, which is what it is in factored form, is 0. So now I know the answer. When x is 0, this will be 0, and 0 times negative 4 will be 0. When x is 4, this will be 4, but this will be 0, 4 times 0. So those are my x values. And the matching y values come from the function. 0 squared over 0 minus 2, 4 squared over 4 minus 2. So those are my 2 points with a horizontal tangent. Number 7, I have a function that looks a little different. Usually we have the x's on the right, but this time the x is on the left. And the x is measuring demand, and I want the rate of change in demand. So rate of change means derivative, and I want the derivative of x. So I need to look at this function, and I need to find out what x prime is. So as I look at 500 and take its derivative, that's 0. When I look at negative p, I'm going to take the derivative of that like I do negative x, and I'm going to get negative 1. So every time I see a p here, I'm just going to think about it like I usually think about x. And here's another function that requires the quotient rule. So I'm going to set up my quotient rule after my minus. P plus 6 squared. P plus 6 times the derivative of 4p minus 4p times the derivative of p plus 6, which is 1. So there's my derivative. They ask me for the rate of change when p is 3. So I'm going to plug 3 in right away. So p plus 6 will become 9. 4 times 3 over 9 squared. And I'm just going to plug that into my calculator. So I have negative 1 minus, and now I've got a fraction coming, so I'm going to put parentheses, and I'm just going to say 36 minus 12 divided by 81. And turn that back into a fraction, negative 35 over 27. But now I realize they wanted it as decimal, so I should have left it as a decimal. Negative 1.29. Or 30. Got to round up. So that's the change in demand. Can you get the charger? This problem is a function that has the defective parts are the function, and this looks like I need the quotient rule because I'm trying to find a rate of change in p. So I need a derivative, but I'm going to do one little change, and I'm going to rewrite the function so that it's easier to take the derivative. So I'm going to grab that 40 and take it out as a 1 over 40 since it's in the denominator. And that's going to allow me to use that as a constant multiple. Technical difficulties, just a sec. Okay, let's try that. Oh, can't see it. Okay, hopefully. All right, so it's not focusing anymore. Oh, there we go. That, hopefully you can see that. So we've got our function p, and we rewrote it so that it's 1 over 40 instead of having the 40 down with the t plus 2. And now we're going to use our derivative rule that says constant multiples can stay where they are. And then I'm going to use the quotient rule on this piece. So the quotient rule looks like square the denominator, start with the denominator times the derivative of the numerator, which is just 1, minus the numerator times the derivative of the denominator, which is 1. And that's going to give me a function that has in the numerator t plus 2 minus t minus 1,330. So that's 1,328 negative over t plus 2 squared. And now I can plug the number 1 in and calculate it. I can plug the number 10 in and calculate it and come up with my 2 rates of change at different times. So this is how fast the defective parts are changing when the time that the person works, the number of days that the person has been employed increases. So plugging into my calculator, 1 over 40, and then I've got negative 1,328 divided by, when I plug the number 1 in, it'll be divided by 9, 1 plus 2 squared. So that will be 3.69 negative. And now I want to plug in a 10, which is going to turn my denominator into 12 squared. So I'm just going to change that on my calculator by doing second entry and changing this to 144. And then I'll get my negative 0.23. So that's how I'm going to fill those in. All right, on to the last page. This time we have a function that is a mystery. We don't really know what f or g are. All we know is that if we take the number 3 and subtract the function g, that's what the function f is. But subtraction, when you're doing derivatives, it has a rule that says if you want to take the derivative, you just take the derivative of each of these terms independent of each other. So that means that the derivative of f is 0 minus the derivative of g. So now I get a connection between their derivatives. And so if I know the derivative of g, I can figure out f. And since they want me to know what f prime of 2 is, that's what they're asking, all I need to know is what g prime of 2 is. But without knowing what g is, I need somebody to have given me that value, and they did. It's right here. G prime of 2 is negative 2. So f prime of 2 is 0 minus negative 2, or 2. I didn't need to know any of those 3 pieces of information. I only needed the g prime. But on number 10, which is a lot like the one we did in class, we have a function that is a quotient of two other functions. So now if I want the derivative of f, I need to use the quotient rule here. But again, it's just the quotient rule in general. I don't know what h is, but the denominator squared goes in the bottom. And it starts out the numerator. And then the derivative of the numerator comes next, minus the numerator times the derivative of the denominator. So that's what the quotient rule tells me to do. But when I want to know what's going on at f prime of 2, that means I need h of 2, g prime of 2, g of 2, h prime of 2, h of 2 again. And they're all given to me right here, the values. So even if I don't know the function, I know what I need to know about the function. -1, g prime of 2 is also -1. G of 2 is 9, h prime of 2 is 8. H of 2 is -1. So I can calculate 1 minus 72 over 1, -71. So as long as I use the right rule, product, quotient, or here's just the subtraction rule, then I can plug in the values that I need to solve for the derivative I want.